Hello friends, before we discuss one more new topic, let us have an introduction about the single line diagram we have prepared here in this plant. So actually this single line diagram we have prepared using very unusual materials, like very strange materials. Can anybody identify it? Yeah, I will take it close to the SLD. Now can anybody guess it? What the material utilized for it? Yeah, if anybody guessing, that is correct. We have utilized a different color 1.5 square mm cable for preparing this SLD, and Cat6 cable, communication cable, and nylon washers, and terminal blocks connectors, and also aluminum conductors preparing these towers. That this base is gypsum board, and above this gypsum boards we have arranged all the cables, washers, connectors, and this communication cables to prepare this SLD. This is represent 3 winding transformers. This is represent 2 winding transformers. Like that, this is the cap of cold drinks bottles. And also color coding also given here. It taken nearly 1 month time to prepare this SLD, and a lot of efforts required. So what do you feel? Is it nice and creative? Please definitely like and comment. Thank you. Yes, this is the generators. So it is our generation is 11 kV. So this is the blue color indicates it's 11 kV. Next taping is the 6.6, 11 kV by 6.6 kV. This is for the boiler auxiliaries. Then again LT auxiliaries, unit auxiliary transformer. This is again 6.6 to 415 volts. So this small Cat6 cable indicates it is the 415 volts. Next, if you see, it is the generator transformer, which will step up into 220 kV, and this is the taping for the Fairvalle's production 11 by 11.5 kV unit ratio transformers. Next, if the red color is indicates 220 kV. So our total switchyard is 220 kV, and it is connecting to main and transfer bus systems. So all red color cable indicates it's 220 kV, and the gray color indicates the 220 kV, but it is not charged. So like that, whatever generation is there after UT, after URT1, then remaining power we are injecting to the bus, and through this grid transformer or the auxiliary transformers we are utilizing for our captive productions, and remaining power we are exporting to the grid. This is the exporting to the grid through these towers is the next connecting grid connectivity substations. Hello friends, today we'll discuss one more topic, that is IDMT overcurrent relay. So IDMT means inverse definite minimum time relay, and actually IDMT is a characteristics. It follows different type of curve. So we'll discuss regarding an application utilizing which we can find out different operating time of the relay when there is a fault. If the curve, particular curve following, whether it is very inverse or extremely inverse or standard inverse or definite time following, at which time that relay will operate, that calculation we can easily find out utilizing a basis. So this is IEC standards. It follows 60255 standards, and it has very inverse, extremely inverse, and standard inverse curve will be there. So these are the curve. So it has inverse definite minimum time. Higher the current, less the time, and lower the current, higher the operating time. This is the characteristics. One more category is the IEEE, the Institute for Electrical and Electronics Engineers. Accordingly, also moderately inverse, very inverse, extremely inverse type of corps will be there. And C08 and C02 standard also there, that also follows in the US. And these are the different core parameters. This is the current versus the operating time corp. So our application designed based on the IC corp. These IC corps are normal inverse, very inverse, extremely inverse, or long time inverse. So SI3 is standard inverse 3 is equal to normal inverse corp. So SI3 and NI are both are same. So that application we are going to discuss based on this IC corp only. Actually operating time equal to K divided by I by IS to the power alpha minus 1 into the time multiplier settings. So the TMS will be given in the relay setting file. So based on the TMS file, remaining what is the setting current, IS is the setting current, I is the fault current, and K and alpha will be constants. The K and alpha values will be vary according to selection of different corp. It is useful during the time of relay testing and commissioning. Utilizing this application easily we can find it out how much time the relay will take if the particular corp selected. Second is that relay coordination also it is helpful. So upstream and downstream that breakers coordinations or the fault clearing coordination also we can do it easily. Third one is if there is a fault analysis system, suppose we are having disturbance recorders. So as per the relay settings, we can find it out whether the relay operated at which time. If the fault current we are having and the setting current we are having, then the fault current actually operating time during the time of fault relay at what time operated. That time knowing means that settings also we can verify it using these applications. So let us go into the applications. So this is the applications. Actually this is a standalone applications. This application does not require any installations. Simply just download it. I will give a link in the descriptions. Simply download it and just double click it, it will operate. So it will open and it will work. So there is no need for any installation. It is prepared using Visual Basic 6.0 and it only works on Windows operating system. There is one more little bit constraint is there. Basic formula actually we have utilized this one only. This is the formula we have utilized this and for preparing this applications. So this is the actually we have to give this corp, we have to select which corp generally we are taking. This is the primary value we can give or secondary value also we can give. Either suppose the city ratio is 300/1, suppose full load current we have taken 300, then we can enter 300. Then enter the fault current maybe 3 times or 4 times we have taken, means we can take 4 times means 1200. And TMS accordingly the relay setting file we can get the TMS. Suppose 0.35 is the TMS. Suppose we take that normal inverse or SI3, both are same. Then if we calculate, automatically this is the relay operating time. If the fault current is 4 times the setting current and the TMS, the time setting multipliers or time multiplier settings is 0.35, then that relay will operate at the time of 1.743 seconds. If the same way standard 1 or SI1 corp if you selected, then if you calculate it, it will be operated in 0.759 seconds or 759 milliseconds it will operate. Like that very inverse also it will give a time and extremely inverse also it will give a time. Like that in each corp we can find it out different time of operations. Suppose the secondary value if you are taking, suppose full load current is 300/1, then 1 amps if you take 10 times the fault current means 10 you can take. Same way, if you select the normal inverse curve, calculate, automatically it will calculate 1.040 seconds it will operate. One example we'll take it. We'll take a clear now. If you will click clear, it will clear. And so we'll take one relay setting files. I kept it here. This is generator bay and generator transformer having that overcurrent protections. If we open it, this is the ABB REF 615 relay, the setting file. In this we will see this is the forward, so it is directional overcurrent relay 67s, ANSI 67s, and it is, see, you can see here IC normal inverse curve select given as that characteristics curve we have taken as, or we have adopted is IC normal inverse, and the IBS current is taken as 53% of the IBS. Actually 53 is the this one 300 amps, so 300 bar 1, so this is 53% taken. So if you calculate it, 0.53 into 300 is equal to 159 amps, and this is the TMS, time multiplier setting given is 0.25. So now we will go to the applications. So like this, so setting current is given as 159, and suppose fault current will take the 5 times, so into 5 it will take 795 amps, 795 amps, and TMS given as 0.25, so it will be like this 0.25. As given the curve is IC normal inverse curve, here it is given as IC normal inverse curve, so we'll select this IC normal inverse curve N9 and calculate it. Now in 1 point, if the fault current is 5 times the setting current, the relay will operate in 1 seconds, nearly 1 seconds. So this is the utilization of this applications. So if you clear it, it will clear. If that secondary, suppose actually if you take a secondary value also, suppose 90.53% taken 0.53, and if you take 50% or 5 times the fault current, the 0.53 into 5 times you take it 2.65. I will take 2.65. I will enter here 2.65, and that TMS value given as 0.25, and if you calculate it 1 seconds it will operate. So this is the utilization of this applications. One more setting file I will show you. This is one 11 kV side settings are there. In this case, that relay we are utilizing is the CGI 14N, and that full load current is that 1500 bar 1, and the setting current is 75% again, that is 1125 amps. TMS is given as 0.37, and the curve given is SI1. So 0.37 is the TMS and SI1 curve given, and the low setting current given is 1125 amps. So if you take this, if you fill this parameters in this one, so 1125 is the setting current. So as I described here, I by IS, that means I is the fault current, IS is the setting current, or the value of relay current settings or the setting current. So 1125 amps. So I will take 1125 into, suppose 6 times I will take, then 6750, and my curve selection is SI1. I will select SI1, and the TMS given is 0.37. Okay. To calculate it, it will operate in 619 milliseconds. So this is the utilization of these applications. And one more important features in this application is that
you all need to enter that setting current in numeric value only. If somebody enter alphanumeric value and suppose just entering roughly I'm entering, then if you calculate it, automatically message will come that enter the numeric value. Suppose I am entering here 1 2 3 4 like this, it will not accept. Suppose 1200, fault current is 1200 and TMS is 0.25. If this TMS value will be, you can get it in the relay setting file. If it is not given, you can take it as 1. So if you calculate it, it will not accept. So you have to enter that 3000 something. Calculate. So in this case now the fault current should be higher than the setting current. So it will not accept the less than value. So I have to enter the 4000 amps. So if you calculate it here, normal inverse, you take it, calculate it, then 6 seconds it will operate. So first thing is that it will not, that entry cell, it will not accept that alphanumeric value. Second, that the fault current should be higher than the setting current. If the fault current is same as that one, it will not accept it. So the fault current should be higher than the setting current. So I will take 6000, it will accept. It will accept. Fault current and should be higher than the setting current. Like that, it will, you can calculate it. Suppose one more like line way, you can take one settings here. It is also ABB REF that 615 relay. In this relay also we can say the settings. This is the settings. The actually city ratio we have taken as 300/1. This is the chord we can see. IC normal inverse chord. And this is the start value 1.10 times the setting currents. So and this time multiplier given as the TMS given as 0.30. And the chord selection is the IC normal inverse chord. So accordingly also we can calculate it. So whether to take primary value or whether to take secondary value, the calculation we can do it. Provided we have to enter the numeric value in the cell. Second one is that fault current should be higher than the setting currents. So after that, suppose the last example I am giving, suppose I will take 1 amps, my fault current is 5 times or 6 times you can take, and my settings is TMS is 0.25. and if I click normal inverse curve, if you calculate it, automatically in 959 milliseconds it will operate. So I'll give a link in the description box, just telling that this application only works on Windows operating systems. It will not work on any Android or any other operating system. Thank you so much for watching this video. Thank you so much.